Test. Okay, it's recording.
Perfect. Yeah, you'll just need to submit that to, I think it's, general.info at ezrarocket.org. That's a link, shareable link to the video review.
Okay, info@ezrarocket.org.
Let's see. Yeah, general.info@ezrarocket.org is what email address you send it to.
I may ask after an email just to make sure.
Yeah, that's fine.
Okay. So let me bring up. I have a separate so I can bring it around. Okay. So to start, here's our rocket. If I can get it in frame. Excuse me, Nathan. So start. It's 114 inches.
So just under 10 feet.
About, yes.
That's just over.
Yeah.
And do you want to walk through what you want to see?
Yeah, so let's start with the nose cone.
Okay. So the nose cone has 12. Can you grab the screwdriver? It has 12 screws holding it together. That way we can access it and put our payload inside of it. Our stability margin is calculated to be 2.8 with this 8.8 pounds in the nose cone. Hold this. So we were using, I'm gluing this in after this meeting. We were using a 3/16 or 3/8 eye bolt with to hold it in using a 11-pound soft shackle and 1/2-inch tubular Kevlar lines. We're using connections. Pardon?
I was just signifying agreement.
Oh, okay. We're using Brummel splices as our connection points. And then for mounting our drogue and our we're using a butterfly knot. We haven't put the butterfly knot in yet, so we're waiting on a drogue. We're using about 31 inches of shock cord for each connection.
31 feet?
Feet, sorry.
I was about to say 31 inches is a little short.
Apologies. And then, yeah. And then we're screwing it in instead of epoxying so we can open it and put the payload in.
So does the payload go above that attachment point for the shock cord?
Yes. And it connects directly to that bulkhead. And that bulkhead right now, because we're working on designing and finishing the payload, is not epoxied into the coupler yet, but it will be for extra support.
Okay.
For this right here is our main chute bay.
Here you go.
Thank you. Sorry, I have an assistant holding the camera.
That makes sense.
This right here, our main chute bay, which pull apart. We have dual redundant Eagle systems for CO2 to power to eject the system. We're using
the CO2 is being stored in the avionics bay, I assume.
Yes.
Yeah.
Okay. Yeah, that'll help with storage.
And we're using. Let me grab my sheet. For the main bay, we're using 2.45 grams equivalent of CO2, so 5 times 2.45 grams of black powder, and 9 number 2 shear screws. Our ground test is. Yeah, sorry, my friend was mumbling something. We're using 5 times 2.45 grams of black powder for the calculation. Our pop test is ready. We're just taking this down to property that's not in the middle of Dallas because the university risk management did not like our idea.
That is a very common response for universities in response to ground testing. So
Yeah, so that's the reason we're behind on that portion. We should get it done this week, though. So, and the main chute we're using is a 120-inch iris chute from Fruity Chutes. We're using our main chute at the nose cone, so when we deploy drogue, it'll separate the rocket into 2 parts, and if the drogue fails, we have high air resistance, and we don't go ballistic.
it's always good. Yeah, so you're deploying the drogue and the main at the same time?
We're deploying drogue at apogee, and then at 700 feet, we're deploying main. But our drogue chute is in this portion. That way, we separate the rocket, and
so it splits in half.
Yeah, it splits in half. Don't go ballistic.
Yeah, that's a pretty standard dual deploy setup. It's the only type that I've used.
Okay, unscrew these.
How many shear pins are you using?
9, number 2 on both the nose cone, and I think the calculation worked out same for the drogue chute. 9 shear pins.
Okay.
Let's grab this. So this is. Yes. What's up?
No, nothing. Just go ahead.
Checking. So unscrew this top bit. We're using a self-contained avionics bay. We have the. Yes. We've done the wiring. We're using 2. We don't have it on the actual piece because we're getting the new bay.
Mm-hmm.
We're using 2 in parallel screw switches in between the battery and each avionics bay independently. So pull it out. So we've designed it to have dual transmitters at both the featherweight GPS tracker and also, thank you.
That's good.
Here, you want to help position it?
Yeah, absolutely.
We're using a featherweight GPS tracker, and we're also using the Telemega integrated telemetry.
Mm-hmm.
And our redundancy, we have a separate featherweight altimeter and Telemega. And then we're slotting. We have the screw switches. I just didn't put them on this board. We're putting 2 screw switches that are both in parallel, so you have to screw both of them in. Or sorry, you screw either one will allow power to the flight controller. So if one of them comes out due to vibration, it'll still have power.
And it would be the same for both of the deployment electronics?
Yes, for all, including the GPS tracker, each of them has 2 in parallel running between it.
Okay.
And
I don't think I've seen that before, but it sounds like a good system.
That's just because we were concerned that if one of them comes out, like cuts off power, and then we don't get a ejection.
Yeah, screw switches can shake like that.
And after talking to our mentor, we did get rid of the screw switches between the recovery ejection system and the flight controller.
Yeah, I discussed that with Ken several times.
Yeah, I thought it was. I heard a lot about ejection systems going off on the ground, so that's why we made that decision.
I only saw it happen once. And I think that was because it was an SRAD system. I didn't really get a lot of information on it. I saw it happen. But yeah, it was a surprise to everyone. But those type of things don't happen very often.
Okay. Yeah, and it's more risky is what we were saying with keeping it, because then if it backs out, then a recovery system's no longer connected. Or connected.
Yeah.
Okay. And for batteries, sorry, I forgot to mention. For batteries, we're using the cell. We're using 2 lithium-ion cells that the manufacturer provided, both for the Telemega and for the tracker. And then for the featherweight altimeter, we're using a cylindrical metal 1.75 lithium-ion. And if there's any concerns there, we can try and switch to all lithium-ion cylindrical cells if necessary.
Let's see. I'm just trying to locate where that part is located. Where it mentions batteries.
Sorry, I don't have the batteries on here. I have them.
That's fine. Let's see. Yeah, so all the batteries match the requirements. Lithium-ion, I believe, does can be used.
And I also have a drawing for each wiring of our system. One moment, let's put that there. So right here, I've put a wiring diagram for the screw switch connections, as well as our main apogee and the backups for both of those, for each flight controller, and then also our recovery system.
Okay. Is this a commercial fiberglass?
Yes, it is Wildman Rocketry, I think maybe.
Okay. Yeah, I figured it looked familiar. I used a Wildman kit for my level 3. And it had that exact type of fiberglass.
Yeah, it's been pretty good so far for the build process. We initially were going to use, if you want to show, we were initially going to make our build out of carbon fiber, but we had a delay that our second tube came about a week ago. So we switched to fiberglass because of that.
Okay. And going back to the batteries, those are lithium-ion, like metallic casing batteries?
Let me grab them to show. What's up?
That's one of them, yeah.
So the 3 batteries we have, this is the one for the tracker that I bought from Featherweight, the commercial one. And this one right here is one of the Telemega ones, 900 milliamp.
Okay, and those were provided with the electronics?
I bought them, they were Telemega labeled for this flight controller.
Okay.
And then these are the ones that I have for the other system. And I'm okay if this one right here for the Telemega is not good enough. I can switch it to one of these as well.
Okay.
I wanted to ask before we did our drain tests.
Yeah, that's a good point. Let's see.
Okay. So, would you like the continuation of the rocket breakdown?
Let's see, just a second.
Okay, sorry.
Don't worry about it. There's a lot of stuff on batteries. Okay, yeah. Yeah, so batteries that are provided by the manufacturer are exceptions to the rules as far as I'm aware.
Yeah, I think Dr. Overton did say something about that as well.
Mm-hmm. Yeah, no, I would definitely trust Ken's ruling, considering that he's the range safety officer for the competition. So if he says it's good, then you're all golden. All right. So that's the batteries. See, what was your drogue chute? I understand it hasn't arrived yet.
So we bought a Fruity Shoot 30-inch drogue.
Mm-hmm.
Can you grab it? It's the smaller one. We talked to Dr. Overton about it, and he said he didn't say no. He said you should try it in your test launch and then buy the replacement. So we went and bought the one Dr. Overton recommended, and we're the Rocket Man reinforced drogue chute. This is what we currently have.
Yeah, that's a Fruity Shoot.
Yes, because it said it was a drogue, and it was bought often with their 120 chute. And on its online calculator, it should work. but due to wind conditions, we're a little concerned that it will tear.
Mhm.
So what we're planning is we'll use this as our pilot chute for the main, because we're using a deployment bag. And then we're waiting for our 30-inch high-strength, wind-resistant one from Rocketman.
Sounds good.
Now if you'll pull.
Okay. So are you using swivel links on everything?
We are not. So Dr. Overton said swivel links under load would usually not twist enough, but for mounting, instead of using hard joints, we're using 11,000-pound rated soft shackles.
Okay, yeah, that would allow twist, yet still allowing for quite a bit of force. Yeah, that makes sense.
The weakest link in our recovery system is currently our U-bolts, which, according to McMaster, only have 1,075-pound capacity.
And that's the strength in the attachment points, isn't it?
Yes. Has a 6,000-pound load. The soft shackles have 11,000 pound. The eye bolts have 1,400, and our eye splices have a minimum of 90% cable break strength.
Okay. Have you calculated the maximum load on the recovery harness?
Yes. So our force calculations from recovery tests were about 282 pounds of force for both.
Okay. And that's at yeah, so is that the worst case load?
I think that may be ideal. We'll have to double check that.
Yeah, let's see. If your ideal is 280, yeah, I can see that you'd be able to hold within the 1,000 pounds for the U-bolt. Yeah, so just double check the worst case, and as long as it has an appropriate safety factor, I don't think it'd need to be 1.5, but as long as you're under at the worst case with a safety margin, that should be fine.
Okay.
Let's see. Let's see, what vent holes do you have for the electronics bay?
Currently, we're installing those after we put the screw switches on the new bay, because we plan to use them for both arming as well as venting it. We're thinking several 1/8 holes, at least 6 of them on the front, so we don't have a giant pressure gradient or wind affecting our barometer.
Yeah, having several small holes evenly spaced is a lot better than having like one large hole. So 6 1/8 should be perfectly fine. Especially if a lot of commercial altimeters will also have recommended vent hole sizes in their documentation. What's the shoulder length on your nose cone?
Nose cone has a 6-inch shoulder length on the external side, and on internal it's about 3-inch because it's as far as you could shove it in.
Okay, yeah, yeah. So the important part is that the non-secure side is at least half a caliber. Anything that's like securely attached with like a metal screw or epoxy doesn't need to be that long.
Okay.
Let's see. Okay, and you're using shear pins to attach the nose cone.
And we are currently determining the best size for our 2 parachute bay vent holes to make sure that we don't make it too big to where our charge all comes out the vent hole, but big enough that we prevent separation from pressure differences.
Yeah, usually like several small holes are good enough to maintain a loss in pressure so that it doesn't just blow out.
Okay.
Let's see. Are there any electronics in your payload?
Yes, but the payload is attached the entire time. It does not need a recovery system.
Okay. And you're securely attaching the electronics in the payload?
Yes, all of it will be attached to the bulkhead, so it can be with, I think bolts is what we're going to do, in the 30 by 10 sat cube, and that way it can be removed for weight and then placed in securely with bolts and armed before we start the launch.
Okay.
I think I have our person who's doing the payload is not here today because he's a graduate student, but we're telling him he's going to use probably the lithium-ion cellular or metal
The
casing.
metallic casing?
Yes.
Okay. Yeah, plus those also have an enormous capacity, which will help. All right. Okay. So, let's see. You haven't painted it yet, so I can't check off that your team number is on the rocket itself. Just make sure that follow the requirements as it goes with attaching team numbers, as well as the, according to this, it's the frequency as well.
Yes, the frequency is coordinated with mission control when we get there. And we are using my call sign for the telemega.
Yeah, so that all that's through DaVinci.
Okay.
Okay.
So currently, we are in the process of finishing our glue for one centering ring and the coupler right here. We are using, the reason it's taking a moment longer is we're doing a redundant motor attachment. So if we come over here.
So are you attaching it at both ends?
Yes. So we have a stress plate, a aeropack retainer on our motor, and then on this side, this is the attachment also to this has a U-bolt that I'm currently double checking the size of before I get. It attaches to the bolt right here. You see the camera. And then that attaches to the front of the motor. And these are both glued in as well. Or this is bolted and the other one's glued in.
Okay. Is there any particular reason why you're attaching the motor twice?
One reason is to give us a strength of attaching everything with a bolt from the battery system. So we have a direct link to the motor, which is holding on the back of the rocket, all the way to the shock cord.
Okay.
And the second is for redundancy in case something goes wrong.
Okay.
As for our progress on the fins, we have glued the fins in, and these are through body fins.
Okay.
Our fillets, we're still applying those. We're thinking about a 7% fillet on each side, as well as we still are doing internal fillets as well.
All right. So so the fins have been glued or epoxied to the fin or the motor mount, correct? But they just haven't been epoxied to the airframe.
They've been epoxied to the airframe. They just have not been
Filleted. Okay.
Yes.
Okay. Let's see. Okay. Let's see. Have you tested that they're firmly attached to the airframe?
Not fully.
Yeah, that works.
To the fillets, but
yeah, that's fine. I was somewhat hesitant with that question because you haven't filleted them yet, so they aren't like fully attached. Are you using a commercial motor mount?
Yeah.
Yes, this is from. This is the Aeropack, and this is a what is it, Apogee thrust plate.
Yep.
We designed our own, and I thought it was too thin, so we bought one. And then we're using an internal motor tube as well to make it easy to slide it in when we have the motor in there. Motor-wise, we have 2 motors currently, so we still can do a test. It came last week, I think, or the week before. And we're using an M2500 White Thunder, I think. Specifically the colors. We're using M2500.
Okay. That's the motor. So it's a COTS motor. That doesn't matter. So you have the motors?
Yes. They're in my possession currently.
Okay. That you don't need. Okay. All right. Yeah, so you haven't done a test launch yet. Let's see.
We plan to be at the May test launch at Seymour, Texas.
Okay. What are your centering rings made out of?
Currently, our centering rings are made out of wood, I think plywood, from Wildman Rocketry.
Okay, yeah, I'm familiar with their centering rings. They use really good materials for those. All right. What are you using for rail buttons?
Rail buttons, we're using, if you can grab them, we're using, you grab the back. So we're using the railbuttons.com rail buttons. I think they're, I always mix up 1515 and 1010. They're the ones on the documentation.
Yeah, it should be 1515. 1010 is for like level 2 style.
Yeah, then these are the 1515 rail buttons. And our plan for mounting is we're going to have 3, and we're going to drill them in at the location of the centering rings. So
Yeah, they will need to attach into something.
Yeah, so I think there's one down here, here, and then one all the way at the coupler.
Okay. Yeah, that sounds good. Let's see. Not yet been attached. The method attaching positions. Okay. All right, so there's that. Now is the coupler is going to be fiberglass?
Yes, and it is on both sides 7 inches.
All right. Let's see. Shoulder length, yeah, extend. Yeah, at least one shoulder length. And you're attaching it with shear pins, correct?
Yes, epoxy on the motor side and shear pins on the other side.
Okay. And it's a commercial coupler?
Yeah.
Yes.
Yes.
Okay. Okay, I'm not seeing any significant slots or holes in the coupler, at least the one you have here. So keep that up with the one that's on its way. All right, let's see, batteries within, hardware mounted. Okay, what is the payload primarily made out of?
It's going to be, I think, there's a set of load cells, and then it's going to be primarily made out of aluminum.
Let's see. Okay. And okay, so it's attached the entire time. It's not going to deploy. Okay. Is it using COTS electronics or SRAD?
It's using COTS electronics from, I think, National Instruments as well.
Okay. They make good electronics. And yeah, that next question isn't needed because it's not deployed. Any deployed payloads would also need your team number on them. But since it's not being deployed, that's fine. Okay. Do I need anything else? That's not there. Okay. Okay. Right. So that's just about everything on my checklist. At the current point, your rocket isn't in a flyable state, but it looks like you have a pretty good set of tasks left to complete it. And you said that you want to test fly in May.
Correct.
Okay. Yeah, that'll definitely help. Let's see. Yet. Sorry, I'm trying to draw on this form with my mouse, so.
We have the components as well if the test launch were to go poorly to rebuild the rocket with the fin slots already done by Wildman, extra tubing, all the extra nose cone. So it should be okay to go to competition, even if something were to go wrong.
That's fine. Goes wrong. Yeah, that's very good. Though this looks to be a very solid rocket. I don't really think anything would go wrong. I mean, if the motor just decides to blow up, but then you have a bigger problem. All right. So there's a couple things which I'd like to bring up, particularly just in case you have any team members that haven't attended Spaceport before. It is highly recommended that you bring your own food and water during the event. There are food trucks, but they do cost money. Let's see. You will need to transport everything yourself to Las Cruces as well as to the launch site. Since you're in the U.S., I don't think you need to worry about shipping.
I'm driving the equipment down as well.
Okay. Yeah, I think that's. Let's see. Have anyone on your team been to Spaceport before?
Not on our current team.
Okay. Just to warn you, there is a border check in between Las Cruces and the launch site.
Okay.
Let's see. Since everyone here is from the U.S., I don't think you'll need to particularly worry. They may stop you. I've been stopped there. When I attended Spaceport, we were definitely stopped. Carrying a rocket in the car is definitely okay. So you will want to bring chairs. However, you don't need to worry about tents or tables, which I'm pretty sure is nice for you.
Very.
That's something new this year is us providing the tent. You'll want to dress appropriately. Temperatures can go above 100 degrees. I think the hottest we got last year was 106. So definitely don't wear black. You'll want hats, sunglasses, sunscreen. I usually reapply sunscreen about every 2 hours. That tends to eliminate the possibility of a sunburn. Let's see, you won't need to worry about that since you're driving. You're all in the US, so you don't need visas. Where are you staying?
We're currently staying at the Marriott Courtyard.
Okay, yeah, that's next to the convention center.
That's convenient.
Yeah, it's a nice hotel. Okay, let's see. You have a ham license
Yes.
and a flyer of record.
Yes.
Okay, I don't think you really need to be told this, but don't paint the rocket in a hotel dorm or in an Airbnb.
Yeah.
You'll there's a reason we have that, but yeah, just to be sure. Okay. Let's see who attended. Let's see. Record. All right. So the only other thing I have for you is make smart choices, be safe, have fun, and don't do anything stupid. Do you have any questions for me? I can't hear you.
That's always good advice with rockets.
Yes. Avoid go fever. I'm sorry to say the Spaceport team that I was on as a student, we definitely did not succeed in avoiding it. We spent about 2 to 3 days of the launch time attempting to get our rocket ready to launch.
Yeah, our hope is not to have it completely done and testable and go to the test launch, and then when we go there, it's all about just, not building stuff or not painting it or anything like that. Not updating firmware while the chargers are connected.
Yeah, that's a good idea. Do you have a checklist?
Yes, I currently have, we're working on the one specifically for Spaceport to make sure we don't forget anything. We also have a full planned checklist for finishing the rocket on time.
Sounds good. Okay.
And for painting as well, going to the point of heat, we're making it mostly red with a little bit of blue. So the fins and I think the nose cone will be blue and the rest is red, which should not drop too much heat when it's in the sun and also be quite visible when it is in air.
Yeah, red and blue colors, they tend not to, I mean, they're not as good as white, but yeah, they'll definitely be better than like darker colors, green, black, gray, dark gray, that kind. Yeah, that should be fine. Plus, even then, a lot of teams will use reflective, like blanket stuff, while they're waiting to go out to the pads.
That's a good idea.
What are the conditions you're using for the battery drain test?
We are going to be running the simulation for Telemega and also Blue Raven. We're going to be fully charging the batteries. I think we're going to leave it for a day, just to assume we charge the batteries, but we had to wait a night. And then we're going to plug everything in, run the simulated, we'll give it a little bit of time, assuming we're setting up, turn all the screw switches, give it a little bit, and then run the simulated flight to launch. The igniters will not be hooked up to the specific CO2 system, but we will blow the igniters to simulate setting off the recovery system.
Yeah, what temperature would this be at?
We'll put it outside, and it's going to be May weather, so it'll be at least 80.
All right. Ideally, we'd want the test to be closer to what it would be at Spaceport, so like 100 degrees.
Okay.
But as long as so as far as I understand batteries is at a hotter temperature, they would just not last as long. So as long as you add in, it's like we tested this at 80 and then that lasted this long. At a higher temperature, they would probably lose a bit of time, maybe, I don't know, 10 to 30% of time. So as long as they last, even with that reduction, say 9 hours,
Okay.
that's more than enough time that they would ideally be on the pad and waiting. Typically, in an ideal, they would only be out on the pad for say an hour, hour and a half total. Okay. Plus then another 30 minutes to an hour for recovery, since nowadays recovery is like really fast.
Okay. Our main concern is we're still debating switching to all of these because they have the same voltage, but they have 10 amps of storage more or less, and the current LiPos we have on 2 of our systems have about 900 milliamps. So we're debating switching because these should last 10 times longer.
Yeah. Yeah. The metal cylindrical batteries have enormous battery capacity. I think that's what one team that I read, the battery test for their batteries lasted for like 50 hours.
Okay.
Which is plenty more than enough time. I mean, 2 days, you're not going to have a rocket out that long.
Yeah.
Do you have any other questions for me?
Anyone? I think we are okay. I'm going to think for a moment to see if I'm forgetting anything. I think I don't have any current questions right now. Yeah, I think we're okay.
All right. Yeah, so once this finishes, if you need the email address to send this to again, just let me know. I'll send it to you via email. You could probably also find it on the HereX page somewhere. But yeah.
Okay.
Looking forward to seeing this fly.
Thank you for your time, Mr. Easton.
Thank you so much.
Let's make sure it records before we do anything. Go to more.
Stop recording.
Yes, click that.